Hi students, let's look at this question which is on vectors taken from the year 2022 paper 1 question 11 from the history math paper. So let's say we can do this proficiently. So a gas company has plans to install a pipeline from a gas field to a storage facility. One part of the route for the pipeline has to pass under the river. This part of the pipeline is in a straight line between 2 points P and Q. Alright, so points are defined relative to origin 0, 0, 0 at the gas field. So this is origin. X, Y are actually the east and north direction, and Z is actually vertically upwards respectively. Okay, so this is actually quite important. What you try to understand is, so this Z is pointing upwards, okay, towards the sky. This is not an issue. Okay, so this is Y. Y is pointing north, and of which this is X, which is pointing east. Okay, this is important. So this guy here is 0, 0, 0. Great. Origin. Now, we are told that P has this coordinate where P is an unknown coordinate and Q is actually coordinate of this. So the length of the pipe PQ is given by 393 meters, given that the level of P is below of Q. So what does this mean? This means that the Z coordinate of P is actually less than Z coordinate of Q. Okay, because it's the level below Q. So we have to know, because find the value of P, this is telling you that there's only one value for P, which is the X coordinate, right? And it is pretty okay. So for A, this is what I'll do. I'll write P and Q in column vector. So it's a 1, 1, 3, 6, 92 P. And Q is essentially just 220 and negative 1, 5. So I know that the PQ is given by 939 meters. What we need to know is actually PQ, modulus PQ, is also equals to 939. All right, so let's just try and count it. PQ is this. So modulus will mean that we just need to square each of it, right? Just square root, then add them up. 936 square, negative 936 square, plus negative 72 square, plus minus 115 minus P square, which is 939. All right. So I'll try and simplify this. I just don't want to put too many squares, so I'll just leave the squares there. Then we're just gonna try and solve this quadratic equation using calculator. Actually, there's a faster way. Could have just left the P plus 15 here, then I'll just square root it later. 939. Of course, we could expand it, so it's P plus 15 square. 939 square minus 72 square, 36 square. So P would be either 21 minus 15. 21 minus 15, that would be 6, or negative 21 minus 15, that will be negative 36. All right, but because we are given that the Z of P is less than minus 15, so it should be reject as P is less than negative 15. Okay, so P is negative 36. There you go. So we got the first answer. I think the subsequent part should be quite okay. So we are given that a thin layer of rock lies below the ground. This layer is modeled as a plane. The 3 points of the planes are these 3 points. Find the Cartesian equation of a plane. I think this is 4 marks. Is quite a doable 4 marks. So just be mindful of each point. Okay, so there are 3 points. Let it be ABC, because they already use PQ. So we let points be ABC. For this case here, we're gonna find the normal vector. The normal vector will just be AB cross AC. It doesn't matter, we could use AB cross AC or BA cross BC and so on, right? So I'm just gonna use AB cross AC here. So this case will get 500 minus 400 will be 100. 200 minus 600 will be negative 400, and this one will be negative 90. Oh, sorry, negative 50. Then for AC, 600 minus 400 is 200. Then negative 940 and minus 50 minus 30. Okay, that's it. So I don't want to deal with such a huge number, so what I'm going to do is just factorize the 50 for the first one. So I'm going to take 50 out. That will be 2 minus 8 and negative 1. Okay. For the last one, I'm just going to take out the 10. There will be 20, 94 and minus 3. Okay, then I'm just going to cross them. I'm going to cross these two. This 50 and the 10, I'll just move them because they're just a scalar multiple. So take 50 times multiplied by 10 will be 500. Then after which I just take these two cross together. All right. All right. So once done, I cross them. I'll get this value here. So then what I'm gonna do is I just take out the -7 as well. So this will be 10, 2, 4. Is it? Oh, we could just take another 2 out as well. So we can take out 14. Okay, this is 500 -17, 2, 512. Okay, so actually what we want is just 512. The normal, the direction which is parallel to the normal is just 512. Just take the simplified form, which is 512. All right, just take this. The scalar multiple, we don't really need to care. So I always tell my students that what we need to do is, if you have a luxury of having 2 or more points, just always check your normal whether it's correct. Because if you don't, then once you get the wrong Cartesian equation, it may affect, obviously it will affect the subsequent parts if we require, right? So I'm going to use point A here. Then obviously I'm going to use point B and C as well to check my R dot N. Okay, so that's what I'm going to do. So I tested all my 3 points and they all give me the same value, so I can be sure that very likely my Cartesian equation is correct in examination. All right, so that's how you do this question here. So hence Cartesian equation is given is 5x plus 2z equals to 2560. So let's look at part C. So hence find the coordinates of the point where the pipeline meets a rock. Okay, I think this is pretty okay. What we need to do is just take LPQ, find the intersection between LPQ and the plane equation. That's about it. So I think we already have got the coordinates of P and coordinate of Q. So just form the line. So just basically the point of intersection of LPQ and the plane. Okay, so that's what we're gonna do. So I'm gonna form the line equation of PQ first. Then I'm gonna just replace into the basically the line equations, replace it into the plane to find where they meet. Okay, it's a line equation where it satisfies the plane equation. So point P and Q, I just replaced the P that we found just now. We already found PQ just now, so PQ was this, right? So we replace P inside to solve. So PQ is minus 936 minus 72 and minus 50 minus P. So just do that. So I got PQ as this direction. I think this can be simplified by dividing by 3, but I'm just too lazy. So essentially this LPQ, which is R, equals to 220 minus 15, negative 15, plus lambda, negative 36. This is a line equation. The lambda is real value. So what I'm going to do is just substitute LPQ into the plane of ABC, which is what we found just now. Okay, so that's it. Just replace it into the what do you call it, the plane ABC, the scalar product from R dot 512 equals to 2560. Okay, so when you dot this, usually what I'll tell my students is just dot across this, then after which you dot them. Okay, because you don't need to expand it, so just dot each. So I'm going to dot this part. Here will be 200 multiplied by 5, which is 1000, plus 20 minus 30. Then after which I dot this part here, this guy, second guy, which is plus lambda. Just multiply them. There you go. Then just simplify them and solve for lambda. So eventually what I get is lambda equals to negative 1/3. Okay, once we get lambda equals to negative 1/3, we could find the coordinates by replacing it into the line equation. Then we should be able to get the answer that is required of us. So taking negative lambda, replace into the point line equation here. We know that this lambda is a corresponding housing address for the point where it meets the plane. All right, so just do that. So hence the coordinates of the point are 512, 44. They want in coordinates form, so you just leave in coordinates form. Okay, 512, 44, negative 22. Okay, that's it. So we look at the last part, find the angle between the pipeline between PQ and mixed with the horizontal. So essentially this is just the angle between the line and the plane. Horizontal is just the plane, the XY plane. Okay, The XY plane is just this plane here, the green color one, with the floor. Meaning to say the XY plane is r dot 001 equals to 0. The normal to the XY plane would be the direction pointing towards the sky or pointing below. It doesn't matter, but the unit vector, which the easiest way is just taking 001 pointing upwards, right? So for the XY plane here. So pipeline between P and Q mixed with the horizontal is not very difficult to understand. If you have a horizontal here, okay, this guy, and you have PQ as such, so this is P and Q direction. The P and Q just now what we found was that it's parallel to what direction? Was it 512? It's 512, right? Use the simplified, oh no, 512 is a normal. So PQ, oh, this is negative 3. Negative 3, I'll just copy it down. Right, this is it. Then what we want is this is a normal pointing upwards here. Okay, so this guy, this is the normal. The normal here will be the nice 512. Okay, if you take this and you dot with this, the angle that you'll get is this angle here, which is, but the angle that you want is this angle here. So usually it really depends if you want to use sine rule or you just want to solve for this angle on top, then just take 90. This is 90 minus alpha. It's really up to you. So I'm going to just use dot product because I think I don't want, usually don't really want students to think that your dot product can be sine. Okay, it's always this guy. So I'm going to just use the n dot d dot n is equals to, this is d mod n cosine alpha. Okay, then once you solve it, I'm just going to take 90 minus of alpha to find the angle between the line and the horizontal. Because they want the acute angle, so I just mod it. All right, just mod it. Then this alpha will just be this angle here. Sorry, I look at the wrong normal. The normal is 001. What am I doing? Okay, it's just the normal of the horizontal that I said just now. Sorry, this is 001. I'm just going to change everything to 001. I think it's much easier. There you go. So we have this alpha here. This will be correspond to 88.71 degrees. So hence, the angle between PQ and horizontal is equals to 90 minus 88.78 degrees. That will be 90 minus answer. That will be 1.8, 1.31 dB. Okay, remember that because you dot product, you get the angle above. Now, of course, you can use sine rule, sine, because just note that you can also use sine because the rationale is because cosine 90 minus theta is equals to sine theta. Okay, so you could, so I usually you could do that. Okay, not an issue. So if you have any question at all, please let us know. And if you have so that's how you do this question professionally, and I'll see you in the next question.